Welcome back. At first, Happy Durga Puja to all my viewers. Wishing that Ma Durga blesses you and your family with happiness, joy and good health, and who is last forever. Today, since every competitive exam will be conducted in December, so since this is the puja times, so just as a review, I will discuss some easy question of differentiability and continuity in functional several variable, which had come in different type of competitive exam, just as a review, because this is the puja time. Okay, so happy Durga Puja again, and see some question just as a review. First question, which had come GATE 2008 MA exam. The question is, let fxy equal to 2xy over x square plus y square when xy not equal to 0, 0. And when f of 0, 0, 0, at the point 0, 0, the value of the function is 0. Obviously, this is the map from R2 to R. The question is, then fx and f of y exist as 0, 0. That means partial derivative with respect to x and with respect to y exist and f is continuous at 0, 0. This is the first option. Second option, fx and f of y exist at 0, 0 and f is discontinuous at 0, 0. Third option, fx and f of y does not exist at 0, 0 and f is continuous at 0, 0. And fourth option, fx and f of y does not exist at 0, 0 and f is discontinuous at 0, 0. Which options are true? For this type of question, there were one easiest method. When f is defined such type x to the power a, y to the power b divided by x to the power c plus y to the power d, where a, b, c, d greater than 0, then f is continuous if and only if a over c plus b over d. If this sum is strictly greater than 1, then we can tell this type of function always be continuous. Other method by polar form, if we put x equal to r cos theta, x equal to r sin theta, just put here, then this value would be 2r square sin theta cos theta. Here x square plus y square means r square, that means this value is sin 2 theta. And for different value of theta, the limiting value, limit theta tends to 0, for different value of theta, the value would be different. So, function is not continuous. But easiest method is this method. Here, fxy equal to 2xy over x square plus y square. That means here a equal to 1, b equal to 1, c equal to 2, d equal to 2. Notice here a over c means 1 over 2 and b over d means 1 over 2. This value is this value of the sum is 1, which is not greater than 1. So by this rule, we can tell easily this function is not continuous. I think this is very easiest method for this type of example. Other method we all of us know, if you put y equal to mx here, then you will see for different value of m, the limiting value it is different. So let's see the option. If here in the option given f is continuous, this is wrong. Second option, obviously true, f is discontinuous at the point 0, 0. Third option is wrong because here also given f is continuous. Only possibility either 2 or 4 because in both option given f is discontinuous at 0, 0. But here more option is partial derivative with respect to x and with respect to y exist? We all of us know fx means limit h tends to 0, f of h0 minus f of 0, 0 over h. And this value is limit h tends to 0, f of h0, just put here 2, 0 minus 0 over h, this value is 0. And f of y means limit k tends to 0, f of 0k minus f of 0, 0 over k. And just put the value, this value would be 0, here 0 over k. So this value is 0. That means fx and f of y both exist at 0, 0. So option 2 is a right option. F is discontinuous but partial derivative with respect to x and partial derivative with respect to y exist. And fourth option indicate partial derivative with respect to x and partial derivative with respect to y does not exist and f is discontinuous. This is the wrong option. Next question, let S be the set of all alpha beta belongs to R2 such that x to the power alpha times y to the power beta divided by square root of x square plus y square tends to 0 as xy tends to 0, 0. Then S contain in option 1 those alpha beta such that alpha greater than 0, strictly greater than 0 and beta strictly greater than 0. Option 2 those alpha beta such that alpha is strictly greater than 2 and beta is strictly greater than 2. Option 3 set of those alpha beta such that alpha plus beta strictly greater than 1. And option 4 set of those alpha beta such that alpha plus 4 beta strictly greater than 1. For this, there are also one easiest method we all of us know. This is if degree of numerator greater than degree of denominator, then the value of the function goes to 0. And when degree of numerator less than degree of denominator, then the value of function does not goes to 0. Here degree of numerator is alpha plus beta and degree of denominator is, and highest degree of denominator is 1. That means here the set would be alpha plus beta strictly greater than 1. Now let's see the option. That means option 3 is a right option. And first option given alpha greater than 0, beta greater than 0. For all alpha greater than 0 and beta greater than 0, this is not possible. If we consider alpha equal to 0.2 and beta equal to 0.3, both are greater than 0. But alpha plus beta not greater than 1. So option 1 is not true option. And option 2 indicate those alpha beta such that alpha strictly greater than 2 and beta strictly greater than 2. For this the option is true. For this, here alpha is strictly greater than 2, beta is strictly greater than 2. But if we consider alpha equal to 1.5 and beta equal to 1.5, 1.7, this sum also greater than 1. But here only restricted those alpha beta such that alpha greater than 2 and beta greater than 2. This is not possible. This may or may not be possible. For all case, for all alpha beta, this is not be true. That means only option 3 is a right option and option 4 is a similarly wrong. That means 3 is a right option. I hope my all viewers have understood this type of question. This is actually rules. This is the easiest method to find this limit. Okay. For this review, today I have discussed this type of question. Okay. Next question. If defined from R2 to R be a function such that f of xy equal to xy over x square plus y square when xy not equal to 0, 0 and 0 when xy equal to 0. Which of the following is are true? Option 1, f of xy is continuous at the point 0, 0. Option 2, integration 0 to 1 and integration 0 to 1 f of xy dx dy is finite. Option 3, f is a bounded function, and option 4, f is continuous at 0, 1. Here, when xy not equal to 0, then since this is the polynomial function and this is also polynomial function, so obviously this is be continuous, but only we have to check continuity at the point 0, 0. For this, we have seen few minutes ago, for this type of question, the continuity when a over c, if and only if a over c plus b over d greater than 1, then function is continuous at 0, 0. Here notice, here f of xy equal to xy over x square plus y square. Notice here a equal to 1, b equal to 1, c equal to 2 and d equal to 2. For this, 1 over 2 plus 1 over 2 which is equal to 1, which is not greater than 1. So function is not continuous at 0, 0. Not continuous at 0, 0. Here notice option 1, fxy is continuous at 0, 0. This is wrong option. And option 4 is imply fxy is continuous open interval 0, 1. This is only not continuous at the point 0, 0. Otherwise the function is continuous. So this is the right option. And for option 2 and option T, f is bounded and this double integration is finite. For this, next double integration 0 to 1 xy over x square plus y square. For this, consider x equal to r cos theta and y equal to r sin theta. Just put the value. Then integration would be integration 0 to 1 and theta lies from 0 to pi over 2. Just put the value. Then this would be sin 2 theta over 2 r dr d theta. And by integration, after integration, this value would be this. And this is be a finite number obviously. So option 2 is a right option. And option 3 indicate is f is a bounded function. For this, fxy equal to xy over x square plus y square. For this, fxy equal to xy over x square plus y square. You can change it by polar form by this method. So this value would be sin 2 theta over 2. Obviously, if we take mod, then this value would be less than equal to half. So obviously the function is a bounded function because mod of f less than equal to half. So option 3 and option 4 is a right option. I hope my all viewers have understood this type of question. Just as a review. Okay. fxy equal to xy over x square plus y square. For this, fxy equal to xy over x square plus y square. You can change it by polar form by this method. So this value would be sin 2 theta over 2. Obviously, if we take mod, then this value would be less than equal to half. So obviously the function is a bounded function because mod of f less than equal to half. So option 3 and option 4 is a right option. I hope my all viewers have understood this type of question. Just as a review. Okay. Next question, which had come CSIR NET 26 November 2022 exam. The question is, consider f which is defined from R2 to R, defined by f of xy equal to 2xy over x square plus y square when xy not equal to 0, 0 and 0 when xy equal to 0, 0. Notice the function f obviously continuous at the point when function not equal to 0, 0, 0, then obviously function is continuous. But we have to check only at the point 0, 0 because here the question about the continuity. And here obviously this type of function continuous at the point 0, 0 when, since here a equal to 1, b equal to 1, c equal to 2, d equal to 2. Therefore, a over c plus b over d, this value is 1 over 2 plus 1 over 2, this value is 1, which is not greater than 1. So, function fxy is not continuous at the point 0, 0. And define a function g of xy equal to series n equal to 1 to infinity f of x minus n comma y minus n over 2 to the power n. Then the question is, which of the following statement are true? Option 1, a is y, where a is y is g of cy is continuous on R for all x. Option 2, g is continuous from R2 to R. Option 3, g is not well defined function. And option 4, g is continuous on R2 omitted k comma k where k belongs to natural number. Notice the function g of xy equal to series n equal to 1 to infinity f of x minus n y minus n over 2 to the power n. Since the function is not continuous, fxy is not continuous at the point 0, 0, therefore obviously this function is not continuous n, because when the value is n minus n means 0, here 0. At the point 0, 0 function is not continuous. So, g is option 2, g is continuous from R2 to R. This is wrong option. G is not well defined function. Obviously this function is well defined. Option 3 also, option 3 is wrong option. And option 4 indicate g is continuous on R2 omitted the set containing kk where k belongs to natural number. Notice this is right option because at the point kk the value is 0. When omitted kk then the function is obviously continuous. So option 4 is a right option. And option 1 indicate the function a is y equal to g of cy. Is the function is continuous on R? Here a is y equal to g of cy, where g of cy equal to obviously this series n equal to 1 to infinity f of c minus n over 2 to the power n. Obviously this is not c minus n, this is y minus n, and here f of xy equal to given 2xy over x square plus y square. This function is bounded because if you put the polar form x equal to r cos theta, y equal to r sin theta, then this value would be f of r comma theta, this value would be 2 r cos theta r sin theta over r square. So this value would be r square would be cancelled, here r square. This value would be sin 2 theta. And if we apply mod f both sides, then this value is equal to modulus of sin 2 theta, and which is obviously less than 1. So since this function is less than 1, that means the function is bounded, and this is actually the series So f of c minus n comma y minus n, obviously this is less than 1, less than equal to the series 1 over to the power n, because this series is bounded which is less than equal to 1, and obviously this series is geometric series. So since the series is, this is the geometric series, so this value is always finite. So if we apply mod both sides, so this value mod of hy, which is actually the series, this value would be less than equal to m. And since this is bounded, so obviously this is a series, so by Weierstrass M test we can tell A is a uniform continuous, and since uniform continuous, so obviously A is continuous on whole R for all x. I hope my all viewers have understood. That means option 1 is a right option. The function is y equal to g of cy is continuous for all a on R for all x. I hope my all viewers have understood. Okay. That means this type of question actually very important. This means this method a over c plus b over d greater than 1, then always the function is continuous, otherwise this is not. This method actually very important. By this method we can construct, this method we can easily solve this type of question. Okay? Oh well. I will stop here. Happy Durga Puja again. May this Durga Puja light up your life, happiness, joy and success. So have a blessed celebration and happy Durga Puja again. See you soon. Stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.